Okay? But today, I'm actually going to mess with that because we are going to deal with situations where the atoms are not neutral. They're going to take on charges. And this is, Tyler's going to talk to us about ions. Okay? Come on, let's go. There we are.
Okay, what's an ion? People talk about ions all the time in chemistry, so what are they? Well, an ion is an atom or a group of atoms that have an electrical charge, okay?
So normally atoms do not have a charge. Normally atoms are neutral, zero charge. But an ion is an atom with a charge.
That's all it is. Now, how does this happen, though? Well, inside atoms, there are two things that have an electrical charge. There are protons that have a positive charge and electrons that have a negative charge.
What would happen to an atom if we changed the number of protons? Say I took carbon. How many protons does carbon have? You should have your periodic table out in front of you. If you don't already, you're absolutely correct, Ryan. It is 6. Carbon is atomic number 6, therefore it has 6 protons. What happens if I change the number of protons to 5?
Negatively charged.
What happens if I change the number of protons to 5, Ryan? Now I have boron. So you cannot turn an atom into an ion by adding or removing protons because it will turn it into a completely different element. Okay? So what are we going to be adding or removing to make ions? We're going to be adding or removing electrons, yes.
A lot of times in atoms, the number of protons is equal to the number of electrons. So the charges balance out and you don't have any total charge. But sometimes an atom can gain or lose electrons so that it gets more or fewer electrons and protons, and then the numbers don't balance out anymore, and it's left with more negative charge because it has more electrons, or it's left with more positive charge because it has more protons. Let me give you a couple examples of how this happens. Let's look at the atom sodium. Sometimes when I'm talking about atoms, I'll just draw them as the element name inside a circle to indicate that that's the atom I'm talking about. But for our purposes, we're going to want to zoom in a little bit more. Here I've drawn two things in this zoomed in version of the atom. I got protons here in the nucleus in red, and then flying around on the outside, I have these electrons, which I've drawn as black dots. If you know a lot about atoms, you might know that I've left out the neutrons, which also live in the nucleus. But it's no big deal because neutrons don't have a charge at all. They're neutral.
Okay, so what's missing from this atom? Neutrons. Do we care about them when we're talking about charge? No. Okay, otherwise we'd have too many particles in the center of that thing. It's just too big.
They're not important for what we're talking about here. Anyway, right now, sodium has, if we counted them, 11 protons here in the nucleus, and it has 11 electrons flying around outside.
So, if it has 11 protons and 11 electrons, what is its net or overall charge? Chat with your neighbor about that. What is the overall charge? You have 11 protons, 11 electrons. What is the overall charge? You can show me. You can be like 1, 2, or are we good with 0?
Yes.
Because we have the same amount of positives and negatives, those charges cancel each other out.
So the number of protons equals the number of electrons, which means that my total net charge is 0. They cancel each other out. And so something that has no net charge, like this sodium atom, we call it neutral. Okay?
So what we're going to do is, just so nobody misses it, we're going to go here and we're going to say, okay, we have our net or overall charge is 0. You'll notice I often put a line through the 0. That's just because I am a chemistry teacher and O looks like oxygen too. Okay, you don't have to put the line through the 0. What means no charge? Neutral. What is the symbol for sodium? Na. Ooh. Where would we put the number of protons in that symbol if we wanted to? Does the number of protons go at the top or at the bottom on the left? The bottom. It goes at the bottom. What would go on the top left? The mass number. Is there any way for us to know the mass number of this sodium atom? Can we know the mass number of this atom that Tyler has drawn for us? We can't, because in order to know the mass number, what do you also have to know? You have to know the number of neutrons. And he's not given that to us, so we don't know what isotope this is, okay? We don't know what version of sodium this is. All right, let's carry on here. You were just not going to put anything there for now, okay?
But here's what can happen in sodium. You see this electron right here? It can lose this electron. It can lose it and it flies off and usually goes into another atom. So let's look at what happens when this electron here gets lost. And now we're going to end up with a sodium atom that has...
It still has how many protons? 11. How many electrons does it have now? Only 10.
11 protons, just like it did before. But now because it's lost this electron, it used to be here, that was here, now it's not here anymore. Now it only has 10 electrons.
What is the net or overall charge of this thing now? 1, plus 1. Okay, so we will, in chemistry, we will say either plus 1 or minus 1. So we don't just say 1 if it's positive, we'll say plus 1. Yes? There's a few little weird rules about how we write it. You can write it as 1 plus, you can write it as plus 1, or if it's a 1, you can just write it as a single plus. And a chemist, like me, will know if you only write plus, you mean plus 1. Okay? For now, I think it's probably easiest if you write plus 1, because that makes the most sense and it'll keep you like on track and stuff, okay?
So now the positive and negative charges don't balance out anymore, and I'm left with more positive charge than negative charge. So this thing now is going to have a charge of plus 1, one more positive charge and negative charge. And so I can write this, if I want to talk about the atom, I can write it.
Okay, and we're just going to fill this in together. So we now have a net. Why is this not moving for me? Where did it go? Good Lord. Okay. There we are. All right. So we have a net charge of plus 1 because we have 11 positives and we have 10 negatives. Our overall charge is plus 1. The symbol for this, Na, do you remember how we have something at the bottom left already? And we have something that goes at the top left, even though we don't know what it is right now? A charge goes at the top right. Okay? So the top right is for the charge. Okay? And you can put plus 1. We'll talk more about like actually how you would write the charge later. But for now, I think that is a very good way of writing it. And you can continue doing that for the rest of the year if you want to. Okay? All right. Now, this is a positive ion. It has a positive charge. Ions that have a positive charge are called cation ions. That word, usually when people look at it for the first time, they look at it and they're like, cation. But it's not cation. It is cat, like meow, ion, cation. And do you know what you see in the middle of the word cation? What's that? That's a positive. The T looks like a plus, okay? There is another way to remember it as well. Cats have what do they have? Pause. What charge is a cation? Positive. Okay? So 2 ways to remember it. The cat has a plus in the middle of it, or cations are positive. Every time you say spatula, I think of this song that my son learned when he was in Scouts. I'm a knife, fork, spoon, spatula, cha-cha-cha, yeah. So every time you say that, that goes through my head. All right, let's carry on here.
It is Na plus to show that it has a positive charge, whereas this, when
So you'll
I'm
notice
talking about a neutral atom.
So you'll notice that Tyler, when he wrote it, he didn't write +1, he just wrote plus. If there is a plus with no number, that means +1. Okay? So you don't have to write it that way, but you should recognize that a plus with no number is +1. So maybe we should jot that down as well. No number equals +1. Okay, so if there's no number, it is +1.
I'll probably just write Na. So Na plus here is an example of an ion. It's an atom that has a charge, and it's a specific type of atom. We have a name for this. We call it a cation, which is what we call an atom. An ion, what we call any ion that has a positive charge.
So you'll notice we don't need to say the word neutral atom anymore, because an atom is neutral, and ion has a charge.
Okay, let me show you another example. Okay, so here's an atom of oxygen. The atom that I've drawn here has 8 protons here in the nucleus, and it has 8 electrons outside.
What is its net charge? 0, because we have 8 positive and we have 8 negative. So if we have 8 positive things and 8 negative things, that gives us a net charge of 0, which means it is neutral. What is the symbol for an oxygen atom? O. Okay, so this is an oxygen atom. Up above it, we have a sodium atom. And over on the right, we have a sodium ion, because it has a charge. Down here, we have an oxygen atom, which is neutral. And then over on the right, well, we'll let Tyler walk us through that. There we go.
So we have the same number of protons and electrons, which means that the total charges balance out. The plus and the minus balance out. So I have a net charge of 0, and I can say that my oxygen atom is neutral. It has no net charge. But oxygen can gain or lose electrons, and actually it really likes to gain 2 electrons. And here's a picture of the oxygen atom after it's gained 2 electrons. And now it still has 8 protons in the nucleus. And if I count up these electrons,
if it has lost, if it has gained 2 electrons, how many electrons does it have now? 10, because 8 with an extra 2 gives us 10.
it now has 10 electrons instead of 8, which it had before.
So what is the overall charge of oxygen once it has gained those 2 electrons? Now that we have the 2 extra electrons. Minus 2.
So now the protons and electrons don't balance out anymore, and I have more negative charge than I have positive charge. I've got 2 more electrons and protons, so that means that my total net charge is going to be 2 minus.
And you'll notice he writes it 2 minus. That's the chemistry way of writing it. We usually put the number first and the charge second. But if you want to write plus 2, that's also fine. Yes? Okay, so let's fill that in. So our net or overall charge, 2 plus, whoa, it's jumping around on me. 2 plus, or 2 minus, thank you. 2 minus or minus 2. Either way is okay, but this is the official way. So positive ions were called cations. Now we have dog ions. No, if only that would be the best. But we have a negative ion, a negative ion, an anion, and it does look like onion, doesn't it? That's actually how I always remember that anions are negative, because anion looks like onion. What do onions do when you chop them up? They make you cry, and crying, well, if it's from an onion, is that positive or negative? That's a negative experience because your eyes hurt, right? So onions make you cry, and that's negative. So 2 ways to remember that one: a negative ion, an ion, or onions make you cry. That's a negative thing. Anions are negative. So we have cations and we have anions. What is the symbol for this going to be? O. And what is our charge there? Negative 2. So we can either write it as O2 minus or O minus 2. The 2 minus is the official way of doing it.
I can write the symbol for this ion as O2 minus to show that it has a 2 minus charge, whereas this neutral guy over here, I can just write O. This is an ion because it has a charge, and there's a specific name for it. We can call this an anion, which is the word that we use to describe a negatively charged ion that has more electrons and protons. Okay, here's just a little bit of vocabulary for review. So an ion is an atom or a group of atoms that have a charge. Okay, now it's possible for an atom to be neutral, which means it has no charge, means it's not an ion.
I think we can do the vocab on our own without Tyler. Let's just go look. All right, so we have our vocab here. Where did it go? Come on. There we go. Okay, so we have ion. What is an ion? An atom. And in fact, for just now, we're just going to say an atom with a charge. And that could be positive or negative. What is neutral? No charge. What is a cation? It's an ion with a positive charge. What is an anion? An ion with a negative charge. Now, just in case you hear me say this word, mnemonic, that is from the Greek mneme, which is to do with memory. So if you ever hear someone talk about a mnemonic device, they just mean a memory device, okay? And I'm teaching you that word because I tend to say mnemonic device, and I don't want you to be like, what the heck is she talking about? Okay, mnemonic, and it's got a silent M. Isn't that fun? Although maybe in the original Greek it's like mnemonic, and the little M is just there a little bit. Could you write, please, 2 mnemonic devices that will help you remember that an anion is negatively charged? And then if you got your 2 negative ones, you can write, actually it says only 1, but you can write 2 mnemonic devices to help you remember that cations are positive. Okay. Okay, so if you've forgotten them, we have a negative ion, or onions make you cry, which is negative. Cats have paws, so cations are positive. And we have a plus sign in the middle of the word cation. Now, here's a new one, which we'll actually be dealing with a lot in Unit 4. Not yet. Do you guys know what the prefix poly means? Yeah, there's polygons. How many sides do polygons have? Can you have a one-sided figure? One side? Is that a polygon? No. Poly means many, right? No, because mono is 1, di is 2, tri is 3, but maybe you don't want to list all of those, right? Maybe you don't want to be like, oh, maybe I have 1 atom, maybe I have 2 atoms, maybe I have 3 atoms. Basically, poly means many, which is more than 1. So what do you think a polyatomic ion is? More than 1 what? Not more than 1 ion, more than 1 atom. More than 1 atom stuck together. With a charge. Oops, I can't spell with. So poly, many, atom, atom, many atom, ion, many atoms with a charge. So maybe you have something like carbon with 3 oxygens on it. It's like a little molecule, but the whole thing has a charge. Okay? Or you might have O and an H with a charge. Okay? Yes? Yeah, so it is an ion. So actually, when we went back up here, when we said an ion is an atom with a charge, it is also a group of atoms with a charge. Or I should say or, not also, or. A group of atoms with a charge. As long as you have the charge, that is an ion. So the important part is with a charge. If you have a single atom, that's going to be called a monatomic ion. If you have more than 1 atom stuck together with a charge, that's called a polyatomic ion. Yeah? How do we feel about ions? We're okay? What kind of particles have to either be added or taken away to make ions? Electrons. Okay. How do ions form? This is now on page 95. Now we're going to talk a lot about how nature likes things. If I let this go, if I let this eraser go, what's going to happen to it? It's going to fall. where is it more stable? Is it more stable up here, or is it more stable down there? It's more stable down there, right? So basically, it's going from, we say that this has a high potential energy. Have you heard that before? High potential energy, and when it falls down, oh, now it's on the floor, it's at a lower potential energy. And nature always tends towards a lower potential energy, towards a more stable state, right? Nature does not, like the ball never rolls up the hill on its own. If you want the ball to go up the hill, you have to push it. You have to put some work in, right? But it's going to roll down all on its own without doing any work. So nature loves things to be stable. Nature loves stability. And when something is stable, it is at a low potential energy. And we use the word potential energy so often in science that we will often abbreviate it just PE. So if you want to abbreviate potential energy as PE, you can do that. Okay? Now, if something is unstable, that's a high potential energy. So if we look at these blocks that are sitting there, do those look stable or unstable? These ones here. Stable or unstable? Unstable. That ball at the top of the hill, stable or unstable? Unstable. Okay? Ball at the bottom of the hill, stable. Now, an ion is an atom or group of atoms with an overall or net. An ion is an atom or group of atoms with an overall charge. In a neutral atom, the number of protons and electrons are equal. In an ion, the number of protons and electrons are not equal. You could say unequal, doesn't matter. Different would also work. Protons have a positive charge. Electrons have a negative charge. If the protons and electrons are not equal, then the atom will have either an overall positive or negative charge. We would call this type of particle that has an overall charge an ion. Okay, so that was just a quick little review of vocab. And now we get to see why they do it. Why would they bother? And now we're going to refer back to the Bohr model. What do you guys remember about the Bohr model? It has shells. How many on shell 1? Shell 1 is full with 2. How about shell 2? It is full with 8. And shell 3 is full with 8. And then after that, it kind of falls apart, so we're not going to worry about it. But what it turns out is that if you fill up an outer shell, so if you have a 2 on the first shell, or if you have an 8 on the second shell, or you have 8 on the third shell, that is very, very stable. What that means is that nature wants to fill up the shells, or it might want to empty them out. Okay? So atoms are either going to gain or they're going to lose electrons. in order to have this stable filled arrangement. And we're going to learn one more vocab word here. The outer shell is called a valence shell. Valence. Now we're going to mostly be dealing with shell number 2 or shell number 3. So we're looking at 8 electrons being full. Okay, 8 electrons is going to be full. If you have 5 or more valence electrons, valence electrons are electrons on the outer shell. If full is 8, if we have 5, are we closer to full or are we closer to empty? Closer to full. If we have 6, are we closer to full or closer to empty? Closer to full. If we have 7, are we closer to full or closer to empty? Closer to full. So if you have 5 or 6 or 7 electrons in that outer shell, the atom is going to want to fill up the shell because it is easier to fill it up because it is closer to full already. So if you have a close to full valence shell, a close to full outer shell, the atom will gain electrons. And why is it going to gain them? Because it's going to fill up that shell until it has 8. Now it turns out that all the ones with 5 or more valence electrons, they all happen to be non-metals. Okay, so if you've got carbon, well, carbon's an exception. We'll talk about carbon later. But if you have sulfur, if you have oxygen, if you have phosphorus, if you have fluorine, all of those have 5 or more electrons in their outer shell. What is the word for outer shell? The valence shell. What do we call the electrons in the outer shell? Valence electrons. What's the outer shell called? Valence shell. What do we call the electrons in the outer shell? Valence electrons. Okay. So let's watch what happens here. Here is a fluorine atom. Fluorine has 9 protons. It has 9 electrons, so its net charge is 0. Could we write the symbol for fluorine? Take a look on your periodic table. What is the symbol for fluorine? It is just F, not FL. Watch out for that. Lots of people want to put an L on there. There's no L. Another thing I want you to watch out for, what is the order of the U and the O in fluorine? It is UO, not fluorine. Now, because you guys are in grade 9, and if you are a person who has difficulty with spelling, I will cut you some slack on fluorine. However, for most of you, you will want to get in the habit of writing UO. Okay? UO. Fluorine, fluorine, fluorine. So it's like getting the flu. Fluorine. Yes? Okay. Now you'll notice fluorine has 9 electrons. So if I was to draw these electrons on from scratch, do you remember where we start? Do we start on shell number 1 or do we start on shell number 2? Shell number 1. And we go 1, 2. And then shell number 1 is full. If that's electron 3 right there, where would I put electron 4? Electron 4, electron 5, electron 6, electron 7. I'm going to skip one because it happens to be the way they drew this diagram, but I could leave the blank anywhere. Electron 8 and electron 9. So we have one empty space. Are we close to full or are we close to empty? Close to full. And when we are close to full, we are going to gain electrons. How many electrons do we need to gain to fill this up? We need to gain 1 electron. Okay, so we end up with that extra one there. There are 2 ways to figure out the charge of this ion. You can say, I have an extra electron. 1 extra electron. Therefore, my charge is -1. Did that make sense? If we have 1 extra electron, we got 1 extra negative thing, the charge is -1. You could also say, I have 9 protons and I have 10 electrons. Protons are positive, electrons are negative. If I add +9 and -10, I get -1. Is good? Okay. So this is a F -1 ion. So normally we would write it as just F minus. And if we write minus with no number, if there's no number with the minus, it means -1. So here we have an empty space. This is unstable. Here we have a filled valence shell. That is very stable. Is the filled valence shell high potential energy or low potential energy? Low potential energy. And now we have an F minus ion. Now, the weird thing about nonmetals is that when we turn them into ions, their name actually changes. It used to be called fluorine. But now that it has a negative charge, it gets called fluoride. Okay? Negative ions change their names. Positive ions do not. And that's the reason why sodium chloride is called sodium, no name change. That's our positive ion, chloride. The negative ion took the ending "ide." Yeah. Do you guys want to try this one on your own? Or do you want to do it with me? One more with me and then one on your own? Okay. One more with me. So we have sulfur. Sulfur has 16 protons. So we can fill that in here. 16 protons. And if it is an atom, how many electrons does it have? 16. What is its net charge? 0. Because it has 16 positives and 16 negatives. What is the symbol for sulfur? S. Okay. Now, let's look at this sulfur. We have 1, 2, 3. Whoops, come on. 3. Remember, you go around like a clock. 4, 5, 6. Then you only double up when you have to. 7, 8, 9, 10. Oh, that's full. 11, 12, 13, 14, 15, 16. How many gaps are there in that outer shell? There's 2 gaps. We got a gap here, and we have a gap here. Is that stable or unstable? Unstable. High potential energy or low potential energy? High potential energy. PE, potential energy. So what is sulfur going to have to do to become stable? It's going to have to gain 2 electrons. If you gain 2 negative things, what's your charge? -2. Okay? So, we're gaining 2 electrons. What color do I want them? Let's make them green. Sure. Okay, there we go. 1, 2. So now our symbol is S. What is its charge? -2, so you can either write -2 or more correctly, you could write S 2 minus. This is more correct. But this is also okay. Because you guys are in grade 9, it's all right. So we still had 16 protons. We now have how many electrons? 18. So that's positive 16 and negative 18. That confirms for us that the charge is -2. And what do we do at the ending of our name? Ide. So instead of sulfur, it becomes sulfide. Yeah, so you guys can now try that last one.
Are you filling in the 2 things?
Oh, what did I forget? Oh, on the next one? Yeah, you're filling in everything. Okay, so give that a go. I'll start you out. It has 7 protons. And remember, one thing that can help is to might draw a little box where you have gaps. You don't have to do that, but it can help you to see how many electrons you might need. Are we going to do the positives? You could if you wanted to. I mean, if you're bored and you want to go ahead, yeah, sure. Not bored yet? Okay. Now, there's one thing missing from all of these Bohr models that I have not told you about yet. When we have an ion, do you see how, sorry, I should put my electrons on here. I forgot to draw those on. It does not show the charge yet, right? That Bohr model doesn't actually show the charge. What we do is we put square brackets around the whole thing. And then on the outside of the square bracket, outside the bracket, on the top right, goes the charge. So that's going to be a 3 minus, and these are square brackets. So if you want to, you could go back to the previous page and fix the two Bohr models on the previous page. Let's go do that. What would we have to do with this sulfide ion? Square brackets. And it has a 2 minus charge, so we're going to put outside the bracket at the top right, 2 minus. And then lastly, we are going to, we've got our, I haven't really left much room here, but we're going to put square brackets around our fluoride ion. And we're going to put a negative charge there. No, yes, negative. Where the heck are all these extra electrons coming from? Fluorine just got an extra electron. Where could it have come from? Some other atom. And if nonmetals want to grab electrons, who do you think is giving them? Metals. All the metals are going to be electron givers. Nonmetals are electron takers. Metals are electron givers. So down here, and this will be the last thing we do for today, we're just going to fill this in here. Where do anions get their extra electrons from? They get them from other atoms. Nonmetals are electron takers. Metals are electron givers. And that means what type of ions will metals form? They will be positive, because if you give away a negative charge, you become positive. Now, your only homework is going to be to study for your quiz tomorrow. Would anyone like another practice version? Okay. If you would like a rich practice version, they are here. Okay, you can come and grab one. If you would like a regular, just leave them there. They can come grab them. If you would like a regular practice version, they are here. You can come and get regular and rich. Regular and rich. Regular and rich. You can take one of each if you want.
Practice up from.
Feel free to take an answer key too if you don't already have one. Just study for quiz. There we go.
Your homework is to study for the quiz. You got this. Good night.
And don't forget, tomorrow is a short day. Okay, so you are done at 12:20 and you're going home for lunch. Okay?
I had a question.
Oh, and there's no break between period 1 and 2. Sorry.
The refrigerator.
Yes.
One's like a freezer.
Yeah, one is freezer.
Which one's the freezer?
The freezer is on the right. Yeah.
If you haven't picked up your phone, pick up your phone. Class ends in about 3 minutes.
Connect charger. Oh, okay.
Sticky notes, quote my face, seriously, try to have it be 6 weeks. Your partner cried, putting sticky notes on your skin for half of them. Hey, I have them.